Hello everybody, this is Jovaida Nahar. My ID is 12008002. Today I will talk about the topic clustering. So let's come to the main discussion. First of all, what is clustering? Clustering is an unsupervised learning method where we group similar data points together. Each group called a cluster contains data points that are similar to each other and different from points in other clusters. We don't tell the algorithm what to look for, it discovers structure automatically. Okay. Then here we have some real life examples of clusters. So first is customer segmentation. So customer segmentation in marketing means grouping customers based on their behavior or demographics. The next is market basket. So it means market basket analysis, finding which products are brought together. The next is organizing documents, automatically grouping news articles or research papers based on their topics. Next, here we have some clustering algorithms. They are k-means clustering, hierarchical clustering, and DVSCN clustering. Clustering is an important because it helps us discover hidden patterns in data without any labels. It simplifies large data sets by grouping similar items, making the data easier to understand and analyze. It also helps in feature engineering by creating new features based on cluster membership. The next slide is k-means clustering. Instead, we have several clustering algorithms. Here we will discuss about k-means clustering. So let's talk about what is k-means clustering. Okay, it's a partition based method where we choose a number k which represents the number of clusters we want. The algorithm then tries to partition the dataset into these k groups based on similarity. Here's how k-means work. Okay. First, we select the number of clusters k. Second, we randomly initialize cluster centers. Third, each data point is assigned to the nearest cluster center. The fourth is we recalculate the centers as the mean of all points in that cluster. And finally, we repeat assignment and updating the centers no longer move much. Okay, here we have an example. Here the example says that perform k-means clustering on given dataset where k is equals to 3. The data points are A120, A225, A384, B158, B275, B364, C112, C249, and suppose A1, B1, C1 as the center of each cluster. Here is the solution. This is the iteration number 1. Here we have already initialized the centroids. The centroids are A1, B1 and C1. Here we have a chart. Here the data points. We have here the total 8 data points and 3 centroids. So we can classify these 3 centroids into 3 clusters. This is cluster number 1, this is cluster number 2, and this is cluster number 3. Here we use Euclidean distance. So this is the formula of Euclidean distance. That means d of p1 p2 is equals to root over x2 minus x1 whole square plus y2 minus y1 whole square. So here is our first coordinates of the data points, which is 210, and here is the first centroids, which is also 210. So the distance will be 0. Next, we will calculate the distance between A1 and centroids number 2, which is 58. So putting this value to this formula, we have the results 3.61, and similarly we have the results of distance A1 and cluster 3, which is 8.06. Similarly, we have to calculate same distance for A2, A3, B1, B2, B3, C1 and C2. Here we fill up these blocks with the resulting output. Here we can see that in the first row, the minimum distance measure is 0.00. So we can say that these data points A1 belongs to the clusters 1. And hence, similarly, we can also say that these B3 data points had the smallest distance measure 4.12. That means it belongs to the cluster number 2. So here we have the ultimate cluster of these measure 1 3 2 2 2 2 3 2. So we can see that here A1 belongs to the cluster number 1 and A2 and C1 belongs to the cluster number 3 and resulting data points are belongs to the cluster number 2. So now we have to calculate the new cluster. So how can we calculate this new cluster? We just take the average of data points of A3, B1, B2, B3 and C2, which is 8 plus 5 plus 7 plus 6 plus 4 divided by 5, and this is result for B1 6, 6. Again, similarly, we can calculate all the new centroids for A1 and C1, which is 210, and for C1, which is 1.5 and 3.5. Then now we have new centroids. Now we have to go to the iteration number 2. Okay, here the current centroids is 210, 66, 1.5, 3.5. So now the new centroids will be assigned to 210, 66, 1.5 and 3.5. So you have to calculate now using Euclidean distance. We have to just calculate the distance between A1 and the A1. So the distance measure will be 0. Now A1 and this B1 will be 5.66, and similarly we can calculate same distance from A1 to C1, which is 6.52. Now we can see that the smallest of these three distance is 0.00. We can say that these data points A1 is belongs to the cluster number 1. Similarly, calculating all these data points, we can see that C2 is for smaller for this cluster number 1. So its new cluster will be assigned to 1. Here, following these two cluster, previous cluster and new cluster, we can see that here is a change. That means these C2 data points previously belongs to cluster number 2, and now in new cluster it belongs to cluster number 1. So we have to proceed for number 3 iterations. Now we have to calculate new centroids, which is A1 3 9.5, B1 6.5 and 5.25, C1 1.5 and 3.5. Now taking the average of clusters coordinates. Now our new centroids are A1, B1, C1 is given here. So we have to go for number 3 iterations because here is a change. Now for iteration 3, here we can see that the current centroids are 3 9.5, 6.5, 5.25 and for C1 1.5 and 3.5. So we have to now calculate the distance for all 8 data points. So calculating from A1 to A1, it will be 1.12. For A1 to B1, it will be 6.54. From A1 to C1, it will be 6.52. So here we can see that the smallest distance measure is 1.12. So we can say that these A1 data points belongs to this cluster, which is cluster number 1. Again, similarly, we can also say that finding this distance measure using the Euclidean distance, we can see that here C1 data points belongs to the cluster number 3. Here the new cluster is assigned to 3. So here we can see that this is our previous cluster and this is the new cluster. So here we can also see a change. That means the data sets B1 is previously belongs to cluster number 2 and now it is belongs to cluster number 1. So we have to proceed for another iteration. So before this iteration number 4, we have to also similarly calculate the centroids for the iteration number 4. Here we calculate the centroids using the same formula. Here A1 3.67 and 9, B1 7, 4.33, and for C1 it is 1.5 and 3.5. So next go to the iteration number 4. Okay. So this is our current centroid, and calculating the distance from data points A1 to A1, we find 1.94, A1 to B1 we find 7.56, and A1 to C1 we find 6.52. Here you can see that the smallest distance measure is 1.94, which belongs to the cluster number 1s. Similarly, if we can see uh, data points B3, the distance between B3 to A1 is 5.52, B3 to B1 is 1.05, and B3 to B1, which is 1.05, and B3 to C1, which is 4.53. So also we can say that here the smallest measure is 1.05. So we can say that these B3 data points belongs to the cluster number 2. So calculating all these new clusters, we can say that the previously assigned clusters and the new clusters are the same. So here we can say that we don't need any further iterations as the previous clusters and the new cluster are the same. So here we stops the our iteration. Next comes to the next slides. Okay, so here we have some challenges in clustering. So what is those challenges? However, clustering comes with challenges. It's hard to know the best number of clusters beforehand. Some methods are sensitive to outliers, and a scaling clustering algorithm is very large dataset can be computationally expensive. So we can also say that to conclude, clustering is a key technique in machine learning for discovering hidden structure in unlabeled data. Different algorithms suit different needs, and choosing the right method depends to the problem. Despite its challenges, clustering remains essential for many real-world applications. This is all of my presentation. Thanks for watching. Assalamu alaikum.